For centuries, the pursuit of knowledge was under the umbrella of natural philosophy. Thinkers observed the world, pondered its mysteries and sought explanations. They were driven by curiosity and a desire to understand the natural phenomena around them, but they lacked a unifying term for their endeavors. The term scientist was not yet coined, and their work was often fragmented across various fields of study. The word scientist as we know it did not exist. Instead, these early thinkers were known by various titles such as natural philosophers, alchemists, and mathematicians. It's strange to imagine a world without scientists, but that was the reality for a very long time. The concept of a dedicated scientist as a profession was foreign to them. This lack of a clear identity reflected a different approach to understanding the universe. Their inquiries were broad and often intertwined with philosophy and theology. Before the 19th century, individuals who studied the natural world were called natural philosophers. They were the intellectuals of their time, delving into the mysteries of existence. They were polymaths, exploring various disciplines like astronomy, mathematics, and physics without clear boundaries. Their work laid the foundation for many scientific principles we take for granted today. These early pioneers laid the groundwork for what we now call science. Their observations and theories were the stepping stones for future discoveries. They observed the stars, experimented with motion, and developed theories about the world's fundamental elements. Their work was a blend of empirical observation and speculative reasoning. These early thinkers, though brilliant, lacked the structured methodologies we associate with modern science. They often relied on intuition and philosophical reasoning. They relied heavily on logic, deduction, and thought experiments, often without rigorous testing against empirical observations. This approach, while insightful, had its limitations. While their contributions were significant, a fundamental shift was needed to usher in the era of modern science. This shift required a new way of thinking and new tools for investigation. The transition from natural philosophy to modern science was not sudden, but rather a gradual evolution. It was a process that spanned centuries and involved many incremental changes. It involved the development of new instruments like the telescope and microscope, which allowed for more precise observations. These tools revolutionized the way we see the world. It also saw the rise of a new way of thinking, one that emphasized empirical evidence and systematic experimentation. This scientific method became the cornerstone of modern science. This shift in perspective would redefine our understanding of the universe and the very nature of knowledge itself. The journey from natural philosophy to modern science was a transformative one, marking the dawn of a new era in human thought and discovery. Today we stand on the shoulders of those early pioneers. Their relentless pursuit of knowledge paved the way for the incredible scientific advancements we enjoy now. The term scientist may be relatively new, but the quest for understanding is as old as humanity itself. As we continue to explore the mysteries of the universe, we honor the legacy of those who came before us. Their contributions remind us that the pursuit of knowledge is a timeless endeavor, ever evolving and ever expanding. From the stars above to the particles within, the spirit of inquiry that drove the natural philosophers continues to inspire today's scientists. The journey of discovery is far from over, and the future holds endless possibilities. The story of science is a testament to human curiosity and ingenuity. It is a story that continues to unfold, with each generation adding new chapters to our understanding of the world and our place in it. Isaac Newton, a towering figure of the scientific revolution, embodied the spirit of natural philosophy. He was a mathematician, physicist, astronomer, and alchemist, making groundbreaking discoveries in each field. His work laid the foundation for classical mechanics, optics, and calculus, forever changing our understanding of the universe. Newton's masterpiece, the Principia Mathematica, published in 1687, presented his laws of motion and universal gravitation. These laws provided a unified explanation for the movement of celestial bodies and objects on Earth, a revolutionary concept that unified the heavens and the earth under the same physical laws. This work remains a cornerstone of physics, demonstrating the power of observation, experimentation, and mathematical reasoning. Despite his immense contributions to science, Newton wouldn't have identified as a scientist. He considered himself a natural philosopher seeking to uncover the fundamental principles governing the natural world. His work, however, transcended the boundaries of natural philosophy, laying the groundwork for modern physics and inspiring generations of scientists. Newton's impact extended beyond his specific discoveries. He championed a systematic approach to understanding the universe, emphasizing observation, experimentation, and mathematical modeling. This approach, refined and formalized over time, became a cornerstone of the scientific method, shaping the future of scientific inquiry. The term scientist emerged in the 19th century, a period marked by rapid advancements and a burgeoning interest in the natural world. This new term was a reflection of the changing landscape of scientific inquiry, as researchers began to delve deeper into specialized fields of study. William Hule, a British polymath known for his contributions to various fields, is credited with first using the term in 1833. Hule recognized that the increasingly specialized nature of scientific disciplines required a new term to describe those engaged in this pursuit. He saw the need for a word that could encompass the diverse and expanding scope of scientific study. Hule, himself a scientist and philosopher, argued that the term scientist was necessary to encompass the expanding scope of scientific study. He believed that just as artists were recognized for their mastery in their respective fields, so too should scientists be acknowledged for their expertise and dedication. He proposed it as an analog to artist, signifying a skilled practitioner of a specific discipline. This analogy helped to elevate the status of those working in the sciences, placing them on par with other respected professionals of the time. This seemingly simple act had a profound impact, shaping the identity and perception of those dedicated to scientific inquiry. It provided a sense of unity and common purpose among researchers, fostering a collaborative spirit that was essential for the advancement of knowledge. Beyond scientists, Hule also coined the term physicist to distinguish those specializing in physics from other natural philosophers. This distinction was crucial as it highlighted the unique methodologies and approaches used in the study of physics. This further highlighted the growing specialization within science, as researchers began to focus on narrower fields of study, leading to more detailed and precise discoveries. The terms he introduced reflected a broader shift in the scientific community towards more focused areas of research. This shift was indicative of the evolving nature of science, where interdisciplinary collaboration became increasingly important. The adoption of these terms was not without its critics. Some argued that they created artificial divisions within the natural sciences, potentially hindering the holistic understanding of the natural world. Some scientists felt that these new terms could lead to unnecessary fragmentation, making it more difficult to integrate knowledge across different fields. However, the terms scientist and physicist ultimately gained widespread acceptance, reflecting the evolving nature of scientific practice. They became integral to the professionalization of science, helping to establish clear identities and roles within the scientific community. Their adoption marked a significant step in the professionalization of science and the recognition of its distinct methodologies. This professionalization was crucial for the development of modern science, as it provided a framework for rigorous and systematic investigation. Today, the terms scientist and physicist are universally recognized, symbolizing the enduring legacy of William Hule's contributions to the scientific community. They continue to inspire new generations of researchers, driving the pursuit of knowledge and innovation. The emergence of the term scientist coincided with ongoing debates about the definition of science itself. These debates were not just academic, they were foundational in shaping how we understand and practice science today. What distinguished scientific knowledge from other forms of knowledge? This question was at the heart of many heated discussions. Scholars from various fields, including philosophy, mathematics, and natural sciences, contributed their perspectives, each adding a layer of complexity to the evolving definition of science. What were the hallmarks of scientific inquiry? Was it the use of specific instruments, the application of certain methods, or the pursuit of particular kinds of questions? These were some of the critical issues debated by early thinkers. These questions fueled discussions among philosophers and scientists alike, shaping the development of the scientific method. The debates were not confined to the halls of academia, they permeated society, influencing how people viewed the world and their place in it. One key aspect of these debates centered on the role of empirical evidence. The idea that knowledge should be based on observable and measurable phenomena was revolutionary at the time. Scientists increasingly emphasized the importance of observation and experimentation in validating scientific claims. This shift marked a significant departure from earlier methods that relied heavily on philosophical reasoning and speculation. Theories and hypotheses, no matter how elegant, needed to be tested against the real world. This insistence on empirical validation was a radical change that laid the groundwork for modern science. This emphasis on empirical validation became a cornerstone of the scientific method. It established a standard that required scientists to back up their claims with tangible evidence. Another point of contention was the role of induction versus deduction in scientific reasoning. This debate was crucial in determining how scientists would approach the process of discovery. Induction involved drawing general conclusions from specific observations, a method that allowed scientists to build broader theories from individual data points, while deduction involved deriving specific predictions from general principles. This method was equally important, as it provided a way to test the validity of broader theories through specific experiments. The scientific method embraced both approaches, recognizing the importance of both observation-driven insights and logically rigorous frameworks. This dual approach allowed for a more comprehensive understanding of the natural world. The scientific method, as it evolved during this period, provided a systematic framework for scientific inquiry. It offered a structured approach that could be applied across various fields of study. It emphasized observation, hypothesis formulation, experimentation, data analysis, and the iterative refinement of theories based on evidence. Each step was crucial in ensuring the reliability and validity of scientific findings, and the iterative refinement of theories based on evidence. This process of continuous improvement and validation helped to build a robust body of scientific knowledge. While the specific steps of the scientific method continue to be debated and refined, its core principles remain central to scientific practice. The legacy of these early debates is evident in the rigorous standards and methodologies that define modern science.